All right, here's another example of a definite integral that uses a U substitution. And here our integral goes from -1 to 0, and we're integrating v cubed over the square root of v to the fourth plus 9 dv. Okay, so for this, we'll want to use a U substitution. And let's think about what we want our substitution to be. So we're going to let u equal some part of this integrand. And thinking about our usual tricks for choosing u, good place to look is inside parentheses or underneath radicals. So that tips us off to maybe using the v to the fourth plus 9 part of this. Another part that would encourage you to use that for your u is the fact that that's v to the fourth. And then up here we have a v to the third, which is one power lower. So that's kind of a good hint that maybe that's going to be part of our derivative. So that's cool. Okay, so both of those point toward letting u equal v to the fourth plus 9. Okay, now we'll take the derivative. Note that this is du dv. We're using a different variable, original variable than we usually do. It's not x, it's v now. So this is du dv, and that would be 4v cubed. Okay, get that differential du, that would be 4v cubed dv. And you know that I like to see what's actually in the problem. And I can see that we've got v cubed dv here rather than 4v cubed vd or dv. Yes, there we go. So I'm going to take 1/4 of both these sides. 1/4 du is v cubed dv. Okay. So that's going to help us make our substitution. We're going to be able to put u in down here. We're going to be able to put 1/4 du in for all of that, v cubed dv. And now we need to address the limits. And just like the last example, I'll do this both ways for you so you can see which option you like best. And I'm going to start with converting the limits. Okay, so our upper limit of integration was v equals 0. And so u is going to be 0 to the fourth plus 9. We are literally just using our substitution equation right there. And so u is going to be 9 for the upper limit. And then lower limit v equals -1. U is going to be -1 to the fourth plus 9. And so that's going to be 10. Okay. So we need to put these things in the right places and convert this entire integral over into terms of our new variable u. And so let's start with our limits here. Make sure you remember to keep your lower and your upper limits of integration in the same spots. Okay, so 10 is going to be our lower limit of integration, and 9 is going to be our upper, okay, because they should go exactly where the corresponding values of v went, okay? So -1 gets replaced with 10, 0 gets replaced with 9. Don't mix those up. All right. And then inside the integral here, we're going to have v cubed dv. Those go together and get replaced with 1/4 du. So we have 1/4 du. And then down in our denominator, we have a square root with u inside. Okay. So let me just clean this up a little bit here. I am going to pull that constant 1/4 to the outside of the integral. Okay, because we can do that. 10 to 9, and then this would be 1 over square root of u du. Just trying to get this in a friendlier format for us. Now, one thing here, notice that if those limits are kind of bothering you, like the fact that 10 is lower and 9 is upper, you can switch those. Remember, we have a property for that. You can actually make this go from 9 to 10. Just do you remember what we need to do if we're going to change those? We need to throw a negative sign out front. So if you want to switch limits, limits, use a negative out front. Okay. So, because remember that property was like integral from b to a of blah, blah, blah is going to be the negative of the integral from a to b, blah, blah, blah. Okay, that's the property we're using here. You multiply by a negative. So you can stick a negative out front here, -1/4, and then you could put the limits going from 9 to 10. That's fine. Or you could leave them from 10 to 9. Either way actually works. Okay, and then we'll have u to the -1/2 du, and that is a pretty nice friendly integrand at this stage. We can take our antiderivative, carry along that -1/4, and then bump the power up by 1, u to the 1/2, so we need a 2 out front, going from 9 to 10. There we go. Okay. And now we're going to evaluate. We're going to have 2 and then 10 to the 1/2, and then -2, 9 to the 1/2. And remember, those are just square roots. 2 square root of 10 minus 2 square root of 9. So we're going to be able to simplify that for sure. Okay, -1/4 times 2 root 10 minus square root of 9 is 3, so that would be -6 there. And then let's see if there's anything else we can do here. Let's put this all into one single fraction. Because actually, yeah, we can reduce some terms here. We're going to be able to factor and cancel out a 2. Okay, that'll be nice. Okay, 2 goes in once, 2 goes in twice. So we'd have negative square root of 10 minus 3 over 2. And then I think I'm just going to go ahead and distribute that negative to make it look a little bit prettier. We'd have positive 3 and minus square root of 10 all over 2 for our final answer there. Okay, so there's the solution to that definite integral. All right. Now we'll do this exact same problem one more time, but this time we will not convert the limits. We'll leave the limits as values of v. So I'm going to take this up here and write the exact same problem for us. Okay, v to the 4th plus 9 was in our square root. Remember, guys, that this denominator does not equal v squared plus 3. Please don't do that with your radicals. Can't split them over addition. It's a constant issue. Okay, a little more constant than we might think sometimes. All right. So since we just did this problem, we know that we're going to let u equal v to the 4th plus 9. That turned out well. No need to change it. Du dv is still 4v cubed. And so we get du is 4v cubed dv. And 1/4 du is going to replace v cubed dv. Okay. And then the option we're choosing here is to not convert our limits. We're going to do it without converting. Limits. There we go. All right. And so if you want to do it this way, You can substitute your u in the same way, and your du there, v cubed dv is still going to get replaced with 1/4 du. And then we've got our square root of u down there. And then the limits, since you're not converting them, do not write those numbers on this integral. This is in terms of u. Those limits are in terms of v. No good, they don't mix. So put some sort of placeholder. u1, u2, or v1, v2, whatever you like. Just do not write those values of -1 and 0. Okay. So in terms of taking this integral, a lot of this is going to go basically the same. We're going to have 1/4. You can pull that out to the front. Du over square root of u. Okay. And then you'll probably want to turn that into u to the -1/2 du. And then you can take your antiderivative. Okay. There we go. And now we're going to take this back to our original variable v. Okay, that way we can actually work with our limits here. All right, so this is going to be 1/4, and then 2, that would be u to the 1/2. Okay, that u is getting replaced again with v to the 4th plus 9. We're switching back to the 1/2. And now you can put your v values back on here for the limits, -1 and 0. Okay, so we got 1/4, 2 square root of 0 to the 4th plus 9, and minus 2 square root -1 to the 4th plus 9. There we go. Got some familiar stuff popping up here. FYI, at this stage right now, you can pull that 2 out, factor that out. Honestly, you can even factor the 2 out at this stage. It's going to be a common factor of both terms, so you might as well bring it outside there to combine with that 1/4. So I'm going to pull it out here, 1/4 times 2. And then we'll have our square root of 9 minus square root of 10. Okay, and so then we can even reduce the 2 over 4 right now, make that into 1/2. And then square root of 9 is 3 minus square root of 10. And then we'll have our answer right here, 3 minus the square root of 10 over 2. And that should turn out to be the same as what we had before, and it does. 3 minus square root of 10 over 2. So you can pick which method you like better. You can do it converting your limits. You can do it without converting your limits. Both work. It's just that one might be easier than the other for you, or one might be easier than the other for a given problem. It's just good to have yourself some options. So there we go.